Can everyone see the screen? You able to see it?
Yeah, we can see your screen.
Okay, sick. Hello everybody. Thank you for coming. My name is Daniel Chow, and I work with Professor Yusan at Cal Poly Pomona to bring you this presentation, an intelligent program to assist in swim training and technique optimization utilizing machine learning and motion tracking. I know it's a pretty long title, so bear with me. If you have any questions regarding this, feel free to contact me at the two emails listed below, whichever one works. And I work together with a group of people who help me with a lot of the code for this project. So a little bit about myself. I am a senior out of high school in the US. I have been swimming since the age of 8, and I am my high school record holder in the 100-yard breaststroke and the 200-yard medley relay. I'm also the founder of the STEM club in my high school, and my interest in STEM was the reason I reached out to Professor Yusan, who helped me create this project. So why did I do something like this? In swimming, every millisecond counts. And if you keep up with the swimming world, some of you might know this picture. It's Michael Phelps out touching Milorad Kavik by 100th of a second in the 100 fly to win his 7th Olympic gold medal. You can see they're very close to each other on the wall. And if you actually search up the race, it's even more close. It looks like Kavik won, but Michael Phelps actually touched first. And every day, technology offers a breakthrough to new levels in every aspect of life, but swimming is missing that technology. And because of that importance of every millisecond, every little movement matters. Angle of pushing off the wall, angle at which a swimmer pulls, and the angle of a swimmer's kick. And these are all examples of certain things that must be paid attention to in the sport in order to guarantee efficiency in the technique. So that brings us to the question, how do we optimize these techniques? And how do we implement technology into swimming? Right? There's so many ways to train in swimming. How can we make sure that we are doing the right thing? And the key lies in the angles. So my knowledge of physics is limited to the level of an AP physics course, but I'm also majoring in it in college. So I do have a passion for it, bear with me. And as many of you may know, a 45-degree launch angle will result in the largest horizontal displacement in projectile motion. And additionally, a billiard ball hitting another billiard ball will make them separate at a 90-degree angle, which is also pretty curious. And the usage of such specific angles can also be seen in sports. We have Lionel Messi. You see that his legs are parallel for better power. You can see the angle at which he leans his body but keeps his head and chest upright. We have Usain Bolt with other runners. You can see there's a 45-degree kind of leaning angle to accelerate, and there's extension points along their leg and torso and head, and they have their eyes and chest toward the ground. And in swimming, I have found that for me personally, a 60-degree diving angle will result in the most speed in my dive. And thus the idea came to me that the usage of so many angles could probably be utilized by motion tracking, or more specifically, body tracking with machine learning analysis. And this can be done using MediaPipe. And if you guys are curious about it, you can visit their website at the link below. Now, with my limited knowledge of code, I was able to use MediaPipe, and what I found interesting was their pose landmark detection, not for its ability to look at different poses, but its ability to use normalized coordinates and world coordinates to locate key points on the human body. And here we are able to see all the key points that it is able to track. We have the nose, the eyes, the shoulders, the elbows, legs, hips, etc., and all which will be used to look at specific angles in the dive later. But this brings up the question, is it possible to even map these onto a swimmer's body and use it to analyze angles? And if it's possible, how do we do it? Well, it turns out we can, and here's the plan in simple steps. We take a video of the dive itself, feed it in a MediaPipe, obtain all the data from it, which are the diving angles, diving speeds, and distance, which will all be calculated using the key points, and feed it into a machine learning program, which will then be used for a train model, which is fed more new data and it turns into results. And the setup to begin the program is as follows. We will need a video recording, pose estimation AI, and lastly, an analysis engine. And the first step, the video recording part, was pretty simple. We obtain a video from any camera, but to make sure the distance data is consistent, we have to consider a few things, which is keeping the camera the same distance from the subject at the same angle and at the same location. And other than that, everything is pretty straightforward. So I ended up doing this at my local aquatic center with a few friends, and I just was able to record from the same distance every time and feed that into the data. But the second step is a little more tricky, which involves MediaPipe in the code itself. So before we get into this, we need to learn more about how does MediaPipe work. Well, it takes an input, we do a little bit of pre-processing, feed it into a pose estimation model, look at key points, and then we do some post-processing, and then we're able to output a video. And let's look at it in a little more detail. So the input and pre-processing part, the input to MediaPipe is typically sourced from a diverse range of sources. This could be a continuous video stream or a collection of individual images. And this input stream serves as the material which MediaPipe's algorithms are applied to, which enables it to perform a bunch of different tasks. And prior to pose estimation as well, input also needs to be altered for resizing and color conversion to make it consistent and prepare it for the deep learning model. And for example, in the code to the right, I had to resize the input video to 480 by 320. That was just simply for the program to run faster. And we had to do a BGR to RGB color conversion, as CV2, the thing that we're using to read the video, only recognizes a BGR color format. Our next step involves MediaPipe's pose estimation model and key point detection. MediaPipe uses a deep neural network, DNN, based on convolutional neural networks, CNNs, to identify key points on the human body. And these key points, including those like the eyes, face, arms, and shoulders, are crucial for understanding human poses. The DNN analyzes the model and predicts where the key points are located on people within the frame. And this process is vital for tasks like motion tracking and augmented reality applications. And then our next step is post-processing and output. Post-processing techniques play a huge role in refining and enhancing the clarity of the results obtained. And this can include various adjustments and optimizations to ensure that the output is as clear and accurate as possible. And once the post-processing stage is complete, the output from MediaPipe comprises a comprehensive set of key point coordinates for each individual detected within the input data. And these coordinates serve as fundamental building blocks, which provide information about the positions and orientations of body parts, such as limbs, joints, and facial features. In this case, we don't really look at facial features, but that's what. And this output is super valuable as it can be utilized for a multitude of purposes, including movement tracking, gesture recognition, and the construction of more detailed 2D or 3D poses. As you can see here, we have been able to map the key points onto the swimmer's body, right? And in this particular program, our utilization of MediaPipe diverges from, the traditional application of detecting poses or counting push-ups, things, stuff like that. And instead, we leverage MediaPipe's capabilities to put these key points onto a swimmer's body to analyze specific techniques and angles involved in the swimming start, which is a critical aspect of competitive swimming performance. When you're in the water and swimming, you will always be the fastest right after the dive. So that's actually why I decided to work on this, because it would be refining such a big technique would result in the most change in swimming. And to facilitate this analysis, the video footage is processed frame by frame and sent to MediaPipe using OpenCV, which is a popular computer vision library. This serves as kind of an intermediary, enabling a communication between the video data and MediaPipe, which is what we talked about before with CV2. And each frame of the video is examined by the algorithms which analyze the different landmarks. And as our code shows, we have various landmarks, including that of, the hip, knee, ankle. Yeah, the hip, knee, and ankle. And it's important that we use 3 kind of positions on the human body, as you need 3 points to make an angle. And the most important angles we will be looking at are the legs and arms and the body or torso angle. Nothing else is really such a big difference where it's very noticeable. And the third component is AI analysis, which will use a trained machine in order to predict and output data. And specific landmarks that are mapped in MediaPipe are used to determine a few data points that are used for the AI engine, including all of the key angles of the swimmer's dive, along with the velocity of the swimmer, which is calculated from the swimmer's displacement and elapsed time from the point where the swimmer leaves the ready position to when the swimmer enters the water. The AI engine takes all of this as a CSV file and selects features from the data frame, splitting it into testing and training sets, and then outputting more information. And the code here shows the different angles of the body at each frame during the video. So, left arm 122, right arm 122. And here's a more clear explanation of the entire process.
This program was created using Python, combining a video of a swimmer with AI landmark detection to analyze and optimize the swimming start. It utilizes key technologies of a recording device, so in this case, a phone camera, OpenCV to read the video, and MediaPipe for landmark and post estimation. From these libraries, I was able to analyze the leg, arm, and body angles of the swimmer because I hypothesized that these would be the most important to gain power in the start. From these, I was also able to calculate out the velocity at which the swimmer would hit the water in pixels per frame. And I also trained an AI by feeding all this information using the sklearn library, creating a data frame with the pandas library, and converting it all into a CSV file. The idea is a user would be able to input a video that they want to analyze. Currently, we are analyzing this video right here, Trevor2.mp4. And once this is done, the program.
And so once everything is done, we get an output that looks something like this. And keep in mind that we're trying to predict how far the swimmer goes, because the farther that they get out is probably related to the speed at which they enter the water and how well they are doing underwater as well.
A video of my good friend David. Upon running the program, it outputs a video that's annotated with all the landmarks on the swimmer. And at the end, it outputs a prediction score of 439 inches. I actually measured the distance that David actually went, which was 425 inches, meaning that there is room for improvement.
Yeah, so to explain the last part, this outputs a prediction score, which are measured in inches. And if I hypothesize that, if a swimmer, their actual dive was less than, this score, they're probably doing something underwater, or they weren't leveraging their strength well enough, even though the angles were all right. So, room for improvement. And at the very end, I doubt this project impressed a lot of you. I believe that it's on a very beginner level, and a lot of people could make this work as well, given the time and commitment and interest for it. But that being said, this is a window into the possibilities of what technology like this, using landmark detection and motion tracking, could bring us. Imagine a program where the same idea of analysis could be used to identify cancer cells in the human body or detect viruses in the air simply by using camera recordings. And if we motivate the next generation to be innovative and curious and to be better problem solvers, we will build a better future altogether. Thank you and have a great day.